So today we're going to talk a little bit about your Chem 131 Lab 8 limiting reactants, and we're going to do this by synthesizing some chalk. I'm going to start by getting my tare weight of my filter paper in a watch glass. So for this one, let's make sure that was zeroed good. And it is. I have 27.162 grams. For the second one, we'll have a tare weight of 27.425 grams. So we have our tared watch glass with our filter paper. We have a vacuum flask. We have our pre-measured calcium chloride dihydrate. For this one, it's 3.001 grams. For this experiment, it's 1.503 grams. In all cases, the sodium carbonate anhydrous should be somewhere around 1.5. I got 1.504 grams for this one, and 1.506 grams for this one. Additionally, I've pre-measured out my 50 mils of water that I'm going to dissolve these in each of these Erlenmeyer flasks. Your vacuum flask should always be mounted down. It should never be freestanding. They are top heavy. They can fall down. I prefer a nice big ring clamp. Doesn't have to be super tight. Just enough to keep it from falling down. So I've added my calcium chloride and my sodium carbonate to the flasks. I've added the 50 mils of water. Right now I'm just trying to get things dissolved. Obviously the calcium chloride went in pretty easily. The sodium carbonate's going to take a little bit longer, so while that's dissolving with a little bit of stirring occasionally, we're going to go ahead and prep our first filter paper. So we put that in, vacuum's going. I want to just wet this down a little bit so my paper adheres to the Buchner funnel. So this is my roughly 3 grams of calcium chloride to 1.5 grams of sodium carbonate. And we're getting close. That one's completely in. This one, a little bit more to go. You want to make sure everything's dissolved, or you're not really carrying out the molar experiment that you're going to calculate. There's just some fine crystals still in there. Alright, so I got all the calcium chloride and sodium carbonate dissolved. And I'm going to pour one into the other. And then back. But I don't want to lose the product that's in here. So I'm going to wash that out. So I'll stir this for a little bit. Make sure it gets good and reacted. While that's stirring, I'll wash this one out a little bit. I want to make sure I get as much of that product out as I can. And if you see white come through, that usually means you didn't get your paper set. Or you forgot to turn the vacuum on and your paper lifted when you poured in. So I have my nice white chalk in here. I'm going to let that dry for a while, just have air blowing through it. When it's done, we'll put it back on its pre-tiered watch glass and put it in the oven to dry. Okay, so it's been sucking dry for a while, so I'm going to try to pull that out. Always want to break our vacuum before we shut our water off. Otherwise the pressure can suck water backwards through the hose, and if what you wanted was in here, you'd be contaminating it. So we'll take this off. Have our watch glass. Now we're going to want to try to get up on the edge. Just clean the tip of that a little bit. I don't like that orange color on there. It's just rust. So I'm going to try to get up under the edge. And I want to try to get that paper to come up. And I want to get my scupula underneath it. Drop that on the watch glass. Just a little bit of product right there. I want to try to scoop that out. Everything you leave behind is product lost. All right, we'll have to live with that. So we'll take it over the oven. Nice and toasty in there. We're up to about 160 degrees Celsius. All right, so our first one should be done. So I'm going to go ahead and come in here and pluck it off with my tongs. And looking at it, my second one, the paper is actually burning a little bit, so we're going to go ahead and take that one out too. All right, so I'll let these cool down, get the masses, and then it's done. Your instructor will send you the values you're going to use for your calculations. So, just one quick visual. The chalk was nice and dry. It fell right off the paper. Now we teared the paper, so the paper has to stay on there. But you'll notice how nice and flaky these things are. So to begin your calculations, you need to know the molecular weight of your reagents and the product. Your next step, see if I can get that glare off there. Your next step would be to convert each amount of the starting material into moles. And you're going to do this to determine the limiting reagent. So my first reaction using 0.3001 grams of calcium chloride with 1.504 of sodium carbonate. It turned out that the sodium carbonate was the limiting reagent. For my other one, it was the opposite, the calcium chloride. So using that molarity of the limiting reagent, or the moles, sorry, of the limiting reagent, you multiply that by the molecular weight of the product to get your theoretical yield. So my theoretical yield for each reaction is here and here. So this was for the calcium chloride at 3 grams, and this was for the calcium chloride at 1.5. In this case, it was the sodium carbonate that was a limiting reagent. In this case, it was the calcium. I'll revisit that. Just to remind you, sodium carbonate here, calcium chloride here. And here's where I calculated my grams in theoretical yield. So I took my tare weight and I took my mass of my glass, filter paper, and product. I subtracted the tare from that. So that's gross tare net. So my net was 1.353. So 1.353 divided by 1.431 times 100 gave me 94.55%. Now you notice on the other one it's only 96.5. I lost a sig fig when I did my subtraction right here. So always remember, sig figs didn't go away after one lab.